Generative adversarial networks, also known as GANs. Let's try to understand how fake image tries to win from real image in this video. All details of GAN with Python implementation. Let's start. So the topics that we are going to cover is what and how of GAN, basically what is GAN made up of and how GAN works. Then we are going to see actually how it works by using generator and discriminator. We are going to understand what are the other important components of GAN. We are going to do a Python demo and I'm going to leave you with way forward and how you can learn more about GANs. This topic is an important topic guys because it is deep, advanced and come with some challenges. So please ensure you watch till end. Why GAN is so much into talks and why there is so much noise around GAN. So basically it has to do with the image generation. And to be more precise, GAN is typically used to generate a fake image. So what kind of fake image it can generate? For example, I have never been to New York. And if you say to GAN, generate an image of Aman walking on the street of New York, and you give some pictures of Aman, augment that, GAN can do that for you. So what GAN does is it can generate the images based on its basically learning, and those images can be fake images and it will look like real images. Now there are obviously ethical challenges and things like that, but this video more focus will be on how GAN works. So to understand how GAN works, right? Just think like there are two friends, A and B. There are two friends, A and B. Imagine that A is a machine learning model. And what is the job of A is A has learned the pattern of identifying if something, some image, is image of a car or not a car. So, for example, this is an image that you give to A, and A can simply tell you whether it's a car, yes, or it's a car, no. This is very simple to understand. Just think like a machine learning model, a classifier, which takes image of a car and it is capable of telling us whether it's a car or not a car. Very simple. For A to becoming capable of doing that, we need to first train A. Okay? Obviously, this is a machine learning model, so we need to train A. Once A is trained and once A is having this capability of saying yes or no to the image of the car, saying yes or no to the capability, saying that having the capability of classifying the image correctly, then what we will do as a next step is we will go to B. B is another friend, and we will tell to B, hey B, can you generate some fake images of car? So what is B's job? B's job is generate fake images. So I will write here generate fake images. In this case of car, you can think of these images. We will pass it to A and we will see what A has to say. Actually, A should say it's a fake image. But if the generated fake image is very good quality, then obviously A will say that it's a proper car. If it's not of good quality, then A will say it's not a car. So one more time, try to understand. A is a model. A and B are two friends. A is a model which is capable of saying whether it's a car or not a car. B's job is always to generate a fake image of a car and pass it through A and see whether A is able to identify or not identify. Now, only two things can happen. Either A is right or B is right. End of the day, what we want to do is we want to make B so smart that it can generate the highest quality fake image so that A is never able to identify it. So what is the end objective here? We are trying to generate the fake images of such high quality that A is never able to identify that it's a fake image. Here I told you A and B, but in the world of generative adversarial network, This is called discriminator, discriminator, and this is called generator, generator. So what is the job of generator? The job of generator is to keep generating fake images. The job of the discriminator is to find out whether it's fake or real. The ultimate goal is generator should be able to generate such high quality fake images that discriminator is not able to differentiate. Cool? So what is GAN full form? So if I come here, GAN, three things only. G stands for generative, generative. And as I told you, the name is generative because we are generating some images, fake images. A stands for adversarial. So the meaning of adversarial is when two things are in conflict or when two things are competing, when two things are fighting to each other. So as I told you, here generator and discriminator are fighting to each other to win, right? Hence this word adversarial, and N is nothing but network. Because we are talking of images here, so we will use some neural network to process these images. So that is what GAN stands for. So if somebody asks you what and how of GAN, GAN is basically made up of generator and discriminator. I told you what these two things do. How GAN works, it's a basically competing mechanism where one is trying to generate, other is trying to discriminate. And important components of GAN, I told you a few things, but when I do the demo, I will show you more things. Let's go to the demo and let's try to understand what is that we are going to do. So I'm going to my Google Colab here and I'll be writing some codes here. But before that, we need some image data, right? So the image data that we'll be using for this purpose is known as MNIST, means data. And I'm showing you Wikipedia page of this. So this is basically a large database of handwritten digits that is commonly used for training various image processing systems. So if I open this, right? So 0 can be written like this, like this, like this, like this. So let me zoom it actually. 0 can be written in many ways, 1 can be written in many ways, 2 can be written in many ways, 3 can be written in many ways. So this is basically, I'm sure some of you have encountered this data before in the world of image classification. So this is the data we will use for training our model. And we will use the either TensorFlow or sklearn data sets to import the data. And we go from there. So let me create a new notebook in Drive. And I will call this GAN implementation. Let me give a name here. For example, GAN demo. So as I told you, if I have to build a GAN network, right, what are the things I need to do? So I need to, first of all, I need two different models, right? So I need to build a generator model and a discriminator model, correct? So I will say build generator. Actually, discriminator should be built before generator. So I will write here build discriminator, build discriminator, okay, then build generator. Then you have to train your discriminator, train discriminator, because discriminator is the model you want to predict what is right, what is wrong. And then you can train your complete GAN. GAN is basically a combination of how the entire training will flow, right? And then what we are going to do, we are going to use that trained model and do the prediction to generate some fake image. For generating the fake image, we will use noise. So I'm going to show you all these steps now. First of all, let me go here and try to import some packages. So I have written some code here, but I'll keep explaining you this code actually. First of all, let's go and import some packages. So TensorFlow Chaos, all these things are normal things because we'll be using TensorFlow and we will be fitting some, basically defining some neural network, right? So I'm importing these packages. Let it import. It's a simple thing to understand. In these two blocks, right? If you see here, right, there are generator network and there are discriminator network. As I told you, two neural networks I need to define, generator and discriminator. What I'm doing here, I'm creating a generator network. If you see here, the input to generator network will always be noise. What is the job of generator here? Come back. What is the job of generator here? Generator's job is always generate fake images. So fake images can be generated using noise. Hence, the input to generator is noise. From this noise, I will simply take a sequential model. I will add a dense layer. I will add an activation function. I will pass it through sigmoid and I will reshape it in 2828. Why 2828? Because the data which we are using for the training, right? The grayscale image is of the shape 28 cross 28. Okay, so that is what is our image? So image size is basically, you can think of 28 cross 28. That is the reason whenever we want to see the image or whenever we want to output the image, right, we have to ensure that it is in 28 cross 28 pixel shape. So if you see my generator here, right, I'm saying reshape my image to 28 cross 28. So if you see carefully, we started from a noise, we did some training here, and what are we outputting? We are outputting an image. That is the job of the generator. What discriminator does? As I told you, discriminator's job is to find out whether something is real or fake. So what input it will take? It will take image as input. Come here, discriminator, image input, sequential model, a flatten layer, because working with image, I want to have it one large array to work with. Then adding a dense layer, and then since it is a classifier, so in the end, sigmoid activation function and just one unit in the end. And what I'm going to get here, I'm going to get a description of the model. So which means whether it is a uh, image, right image, or not the right image. Fine. These are the two models, just the model definition. I ran it. Now let me go here and try to copy some more codes. If you see this part here that I'll be pasting now, if you see this part, right, as I told you, we need to define a noise dimension. So whenever I want my generator to generate some image, right, I have to fix a noise dimension that I will give you this size vector for generating images. So noise dimension is 100 in this case. I said you my image shape is 2828. This is the shape. Now I'm initializing the components. So discriminator is create discriminator function I'm calling, just compiling the above thing I'm calling and just compiling. The generator, I'm just passing a noise. I'm just passing it through chaos input. Generated image I'm getting. And if you see, this line is pretty important. Discriminator.net.trainable false. So when your generator is generating fake images, you cannot change the weights of discriminator. So both things cannot happen together. Discriminator is trained, then only you are passing the images to be set as 0 or 1. Both things cannot happen together. So when I'm into generator phase, so basically it's a two-phase training. First phase, discriminator get trains, but when I move in phase 2, right, then generator gets trained, not the discriminator. Okay, so here what is happening is discriminator dot trainable is false, and here I am taking the output of the discriminator. So very simple. First discriminator gets trained, then generator starts generating the fake images, and then we are just getting the output. Till here I am not training the model. What I'm doing is I'm just keeping it, preparing for it, and then I'm combining generator and discriminator, if you see. So I'll just run this, and if you see, I'm combining GAN model is equal to noise output and validity output. So one is noise that I'm generating, noise from where I'm generating generator, validity output from where I'm generating discriminator. Okay, and then since it's a two class thing, binary cross entropy and atom, let's run this part, and let's go here and now define our training function. Okay, so I will go here and I will paste my training function. Training function is not difficult to understand. As I told you, I will be using the tf.keras.minst load data, scaling the data because it is a good practice image kind of scenario, scaling the data, expanding dimensions to fit. I am generating some labels here. Real labels is np.ones 1, those many 1 will be written. Fake labels np.0, those many zeros will be written. I am generating some test data here, which is real data. I'm generating some noise data here, which is not real data, fake data. And here, at the moment I say train on batch, right? This part to this part will train the discriminator, and this part to this part will train the generator. GAN model basically. If you see GAN model, train on batch. So what is happening as part of this function is, from here to here I'm data preparation and discriminator training. From here to here actually GAN training. And what I'm doing here, I'm printing epoch and gain loss. That is generator loss. GEN gain loss means generator loss. Okay. I'm interested in generator loss basically because I want to make my generator super smart. Fine. I will give you this notebook in GitHub. Don't worry. Just try to understand which part is doing what. Then you can play with that. This part to this part generator. This part to this part. I am just trying to optimize the gain loss. I am printing the gain loss with every epoch. But there is one issue. If I run this, I want to run this on more than 10,000 epochs. But if I do that, right? As you know, image data is resource intensive. It will take like maybe half an hour or more. So what I have done is I have trained it and kept it in my Google Drive, which I will load now. Just to show you that it works, I will just run like this. As you can see, on one epoch it got trained, just one epoch. But one epoch is useless basically. You should make it 10,000 minimum or 20,000, 30,000, and then run it. Remember, when you want to run it, right? Change your runtime from here. So here you go, change runtime, T for GPU or TPU B2 at GPU. These two GPU you change, it will run fast. Otherwise, it will take a lot of time. In my case, I have utilized my GPU for this account. So, but I anyway have the model, so I don't bother. Let me go ahead and load the model. So I have the model loading code here. I have that model in my Google Drive. Okay. So this is the path where my model is, and this is how I'm trying to load the model. So let me run this. It is telling me connect to Google Drive. I will do that. I should use a different account actually, because on that account it's not there. Let me try using. So if you see here, I have created the same GAN demo file in my different Gmail account. This is basically Unfold Data Science Gmail account. The previous one was my personal Gmail account. So in Unfold Data Science Gmail account, I have that model actually. So now I'm able to import that model. If you see here, same code I ran, model got imported. Now I will show you how to predict using that model. So I'm pasting this code. What should happen for prediction? If you come here, right? For prediction, you should give a noise to model B to generate image, right? So I'm giving a noise here. Z is my noise vector. Okay. And then generated image is my generated image. I'm trying to plot using matplotlib. So let me try to show you how it is plotting. So if you see here, right, it is looking something similar to 7. It's not a great image, obviously. And this is looking something similar to 1. And this is looking something similar to maybe 9. This is looking something similar to maybe 5 or 8, not sure. But few things here. This is a fake image. Remember, this is a fake image. I have not used any fancy infra. I have not used any fancy training. I have not used any fancy model. My all models is very, very simple models. Simple models, simple architecture, simple training data, simple infra. For image kind of scenario, you need large training data, heavy infra, and complex models. But concept remains same. I want you to take this model, change the epochs, change the batch size, and try to see you should be able to generate images similar to what you saw in the Wikipedia. That is a good model basically. This model, it's easily somebody can say it's a fake image. Ideally, nobody should be able to say. And then try to play around with how the model is designed, a number of units, number of layers, number of functions, whatever, right? So I will quickly reiterate what all we learned in this video. What is the basic of GAN? How generator works, how discriminator works, how they compete with each other to bring a finer GAN network or generator, important components, Python implementation, and then way forward. Please give me a thumbs up if you like this kind of video, guys. I'll see you all wherever you are. Stay safe and take care.